Okay, how we doing? Today we're going to do a video on Honda canister purge solenoid, but in this aspect it can apply to any purge solenoid, any duty cycle solenoid that's computer controlled. Could be an EGR solenoid, could be a purge solenoid, could be a vent solenoid, could pertain to variable valve timing. We want to see the action reaction of a solenoid, and in this case we're going to use a 4-channel scope. We're gonna, as you can see in the illustration, you want to take a snapshot of that. That is not the whole evap system. That's just the components we're going to look at. We're going to look at the canister purge solenoid. We're going to look at the fuel tank pressure sensor. That is down by the fuel tank. And we're going to look at that pressure change. We're going to watch the computer duty cycle ground side switch the purge solenoid, which would turn the constituents inside the evap system into the intake. It could most likely could be hydrocarbon, most likely could be air, depending on how saturated or unsaturated the canister is. So as you can see in your illustration, we have a purge solenoid. We have what I wrote on is the canister. That's that purple thing in the middle. That's basically the whole evap system. I have omitted a canister vent solenoid. Of course, this car does have a vent solenoid, which is most likely open as we run through this entire test. Nonetheless, we're going to see the effective vacuum going into the evap system as the PCM duty cycles the purge solenoid. So just take a look at that, take a snapshot, and I will go to the scope and we'll start the car and start running. Here's our setup. Here's the engine. We're on the scope. Car is not running. We will get it running and get you set up and talk about the action reaction. So here we go, starting the car. Alrighty. We are idling. The scope is started now. We're running across the screen. As you can see, your 4 channels. I neglected to tell what they were. We're looking at A, B, C, and D. A is blue. That is our WPS 500 on range 2, keyed into the vacuum line in the canister on the evap side of the purge solenoid, not the intake manifold side. Channel B is our duty cycled at the PCM ground side switch control. Channel C is at the fuel tank pressure sensor signal wire at the PCM. That's the wire that changes depending on the pressure or the vacuum in the evap system. Channel D is we're current ramping the canister purge solenoid. So we're going to see the action reaction. So let me get this straight. Let's get to a little better zoom. Right now we're idling, and I'll stop the scope and we'll talk about it. Okay, what we got here is a very, very low, we got a very low duty cycle, and we really can't pull much vacuum into the system. As we look at our blue and our green, our blue is the WPS, that is in the evap system, and our green is the fuel tank pressure sensor for the evap down by the tank. So as we can see that, we kind of open up, we see very slight pull, not much of a vacuum effect on that. It's going to get more stronger as our duty cycle continues. So I'll go back, turn the scope back on, and we'll watch it, and things are starting to change now. Now we're getting up, it's idling. Evidently it purges at idle. We'll clean things up and stretch things and they'll look better. I'm going to give it some throttle and keep an eye on the 4 channels. I know green is kind of hashy. I will filter that when we analyze it. Let me give it some throttle. All right, you probably noticed something there. I did disconnect the solenoid for a very small amount of time just to see what it looks like if we're diagnosing an intermittent connection. Nonetheless, I will stop the scope, stop the car, and we'll look at it. Let's roll back to the beginning of the capture. Okay, how are we looking on the scope? All righty, beginning. Okay. Okay, here's our beginning. Okay, let's take a look at what we got. We got 4 signals, and we can see our duty cycle looks about 50%. That's the red guy. That's the PCM controlled duty cycle of the solenoid. Our green guy is our FTP sensor. That's pretty good. I got to stretch that one a bit. You can see when we have when the solenoid opens, our voltage would be going lower. That would imply vacuum. So once that duty cycle, for that moment in time when that canister purge solenoid lifts, the engine vacuum gets into the evap system and would pull that low. And our WPS is also going low. So not by a whole lot, so we can see our delta in our transducer from top to bottom. We're looking about 2.9, let's say 3 PSI, about 6 inches of vacuum. This is a very tightly monitored system, so they're not going to get the full 20 inches. This is basically pulling some unburned fuel into the engine to be reburned, so it doesn't get into the atmosphere. This, of course, is an emission control system. And bear in mind, sometimes canisters are empty in there. You're going to get more air than fuel. So it's dependent on how saturated or unsaturated the canister is. As we continue to look, let's look at our current. That is in purple. I know it's hard to make out. That is a current ramp. That current goes up as our voltage is pulled low. As we can see it, we've seen that in other videos, fuel injection style videos. This is kind of the same principle. Let me see if I got a pintle hump. I don't know if I do. Possibly there. I wouldn't bet money on it if that's particular. But one thing we can infer that we know this solenoid moved because we see a dynamic vacuum change in 2 different spots. We see it on the WPS and we see it on the fuel tank pressure sensor on the car. So that's definitely a validation that this solenoid lifted, the system got a shot of vacuum, and then it closed real fast. It's a frequency type a solenoid, but nonetheless, let's go down the capture and see if we can see anything else. Now here's where I disconnected. Okay, that's right here. We can see something happen. We had a little disc. This would definitely mean a broke connection here. We stopped. We had no power to the PCM because the system was broken at the purge solenoid. So current stops flowing, vacuum stops flowing into the evap system, and looks like the fuel tank pressure sensor validated that. If we had a leaking purge, physically leaking purge solenoid, we may see vacuum in a case like this. Just something to bear in mind, so we can pretty much say that this purge solenoid is not leaking, it's not flowing vacuum, and it's not commanded to do so. Nonetheless, we'll go down the line and take a look at some others. Basically, we got our vacuum pulls as the solenoid opens. We got our current flowing, and let me stretch the green guy a little bit because that's a very. Let me give that a little bit of a stretch. Okay, greenie, come on. Okay, now we can see our green. That's the ability of the scope to have a lot of vertical zoom. We can just see how our blue, our transducer, and our fuel tank pressure sensor are kind of lined up. That's a good validation that our fuel tank pressure sensor is accurate. It's working, and it's in its right zone. It's in its right level. If it were skewed, that could definitely cause a problem, cause evap codes, things like that. So right there, we see all the action-reaction on our canister purge solenoid. So if you ever had one, sometimes these vacuum switching solenoids can be very intermittent. I've seen them come with a check engine light, an evap code. You test them 30 times and you cut the car loose and it comes back 2 days later. It runs the monitor and it fails it because they're very intermittent. With this method, we may be able to pick something out. We may see an anomaly in this circuit, so we'd know where exactly to make our diagnostic decision about what component we're going to change. So anyway, signing off, all the best, and thank you very much for watching.